Professor, if you're trying to say something, we cannot hear you.
I was sighing. I was sighing at crappy user interfaces. Okay, hey everybody. We don't have a camera on yet. All right. Hey everybody. Here's what we're doing today. Going over P5, P6, and yeah, this course is called Computer Organization, but I use it to get you a lot of information that you should have that you just don't get anywhere else. For example, we did unions, which you didn't learn in another class, and we also did bit fields, which you didn't learn in another class. So these are all important things. Today, we're also going to cover Variatics and start our exploration of bit twiddling. Okay.
Yeah, when did we do the union things? I don't remember off the top of my head.
Well, we did. I don't know the day off the top of my head.
I was kind of referring to what project we used it in.
It was the float, where we tied the float to the other value via the union.
Thank you. See, code goes in, code goes out. I don't pay attention. Don't tell anybody, but I pay as much attention to what I teach as I do to what my wife is telling me, which is very little. But don't tell her. Okay, no, seriously. We did unions, as was said, when we were doing the float. By the way, do you have any questions on unions? Any questions on bit fields?
Most of my questions relate to utilizing the VAD F32 thing that you're having us do.
Okay, then articulate a question and let's answer it.
All right. With the advice you gave us on GitHub, you mentioned that it takes in floats plural, then returns floats plural, and do not tell us basically anything else. However, when attempting to use a float pointer, the thing that you have us use for inputs, it does not accept those, and even when using a proper vector, it doesn't accept those either.
All right. Would benefit, I think, from you sharing your screen. So let me ensure that you're able to do that. And why don't you show me an error message? And try to show only the part that you're having a problem with so that we're not looking at all of your code.
I'll just show you my ARM machine, which has the error code in it.
Mm-hmm.
All right, I'll share my screen. And I'm only sharing the Ubuntu. And this is what my problem is looking like. I've basically been trying and meddling with a bunch of different ways to try and get the function to work, and none of them have been seeming to want to work, including casting everything to vectors, casting everything to the float 32x4_t, which is what it wants apparently, and they all just do not let it compile.
Okay, so I'm looking at an awful lot here, and of course, there's so much here that I'm confused.
I'll just scroll down to single out one of these.
Mm-hmm.
All right. As we see here, I cast these to a pointer and then increment to the next one. And I then do the same for B, which is the two inputs for the VADDQ F32 function. And it says they're expecting something else. And this is the same as me doing this, but doesn't particularly like that. And it says cannot convert float to float 32x4t, aka vector 4 float.
Okay, well,
I'm basically just blanking on how I convert these things properly.
all right, well, you've got problems in your syntax for sure. And you know that what the signature of the function is, right?
It returns a float. At least. Cool. With the website that you gave us for ARM, for the vadd function, it returns a vector of floats.
Okay, all right, well, you can stop sharing. And let me share my iPad. And so you can see my iPad, yes?
We currently see the notepad with the agenda of P5, P6.
Good, that's what I meant. All right, so float 32 times 4 underscore t is a type that is an array of floats, right? But it's not an array. It's 4 floats at one after the other. But where you would use the name of an array is a pointer to the array. This is a little different. So you're given float star, right? A, B, and C. Okay, so if you have a float 32 by 4 underscore t pointer, V equals, then cast it, float 32 by 4 underscore t star, let's say array A. I don't care, but that one's a float star. Okay. Okay, so A is a pointer to 4 floats. Well, it's a pointer to all of your floats in an array. Well, right now, star V is one of these. So that's what you're passing. Are you following me, Thomas?
To a degree, but it only gets the first of the floats from A, or it gets the first 4.
After doing this, you've got the first 4 floats of A, which can be gotten to via that.
Okay, and wouldn't this be really inefficient to need to recast the thing consistently in order to get to the next 4 floats?
Well, remember, no, it's not inefficient. Remember that address arithmetic does the right thing when done by the compiler. So if you say V++, that's going to...
It goes to floats 4-8 from
4 to 7.
0 to 3.
Right. 0 to 3,
Okay.
then 4 to 7, et cetera, et cetera. 8 to 11. Okay. So the syntax that I used when I wrote this I've got parameters A, B, and C, which are all float stars. But then I also created float 32 by 4t pointer, A, the vector form, B, the vector form, and C, the vector form. And I did the appropriate initialization.
And then we can just move the things back into C.
Well, there's a CEV that's going to do the moving back into C.
That's what I was referring to, and we might need to loop through that one.
Well, you loop through all three, right?
Yeah.
Because it's A index 5 plus B index 5 goes into C index 5, right? So you're going to loop all three.
Mhm. I was just forgetting that the pointer would also change the thing that it's originally pointing at.
Okay.
It's the extra level of abstract thinking, which is like, how is that supposed to work? And I thought I had to move things back and forth a little bit more.
No, and remember, there's no real complexity to a cast. Casting is influences how instructions are generated, because in the assembly language, there's no such thing as a float 32 by 4, right? I mean, casting is just influencing how instructions are being generated. So there's no inefficiency in it. Okay, other questions about project 5 or 6?
Yes. So if I run it on my virtual machine, the Debian that we downloaded, I would have a different amount of cores than if I ran it on my Mac itself. And the alias that we downloaded is configured to only have 2 cores, like in any case. Okay.
Right. Right. And unless you have an M1 based Mac, you can't run it on your desktop, or unless you're running a Windows ARM-based machine.
Okay. Thank you.
I know you showed us this last time, but could you by any chance demonstrate again how the program should function for P5?
Sure. Let me see if I am configured to do that. Let's see, what is this? Let me make this smaller so you can see a terminal window, right?
Yes.
And is it showing just a directory? I think I'm going to have to. That's not the right directory. This is not the right directory. What have I got here? So I'm pretty sure you're not seeing the right. Yeah, I'm not even running the ARM machine yet. Okay, so let me stop the share. Start it over again because Zoom doesn't understand tiled windows. All right, so let me launch that. Give that some time. And go find another tab. Okay. This is really inconvenient. Okay, so what do you see now? You just see Doniger Arch 64?
Yep.
Okay. What do I got here? P5. Oh, looks like I still have P5. Okay, so /a.out-h will give you the help. So let's set the size to 100,000. And we can set the number of iterations to 20. Okay, is that what you wanted to see?
Yes, so I guess one of the questions that I came across was for the first portion of the project, my output for the naive is different. And I wasn't sure because I know like we're using random numbers. So I wasn't sure like if those are supposed to completely match or if it is supposed to be different.
Now, they will be different every single time you run. Here, I'll run the same program again on the same machine, and I've got different answers. What you should be looking for is the size is 100,000. Whatever number you put in there, the check value should be close.
And that the check value should all match.
And the check value should all match between all 4 runs.
How close should it be? Like within 100 or?
Yeah, within 100 or so. Here, I'll run it a bunch of times. Okay, well, there's one that's off by 238. Off by 215. 247. 66. You get the idea.
All right, thank you.
All right. It should be roughly the number of floats. And it should go up and down. Right, so that now it's more than the number of floats, and the other times was less than the number of floats, but still relatively close. You know, if you want to make it 1,000,000 floats, it's still within the range of a few hundred. Okay. Okay, other questions? Project 5 or project 6?
I think we're waiting to start on project 6 before we ask questions about it.
Okay.
So I have a weirder question. So randomly, I can't program anymore in VS Code. It seems to error out and can't find any of the C++ files like in the includes. So it's erroring. So I'm not sure. I couldn't figure out how to do it. So I've been just kind of messing around and like making stuff in Xcode, but obviously I can't run it on Xcode because I can't run the virtual machine. So I don't know how long it'll take, but could you help me figure that out like sometime after class later?
Sure.
Okay, cool.
Sure. Let's make an appointment for sometime in May.
Oh, cool. Yeah, I'm sure that'll be helpful.
Yeah, I'll have plenty of time then. So will you.
Yeah.
Yeah. Okay, sure. Just make an appointment anytime.
Okay. And today works, right? Because you said usually.
Yeah,
you don't like
today, I mean, I'm not, I don't jump at the chance for appointments on Tuesdays and Thursdays, but I can handle it.
Okay, cool.
So after 4 today would work.
Cool.
While I said that, let me just check my calendar and get accurate information. Yeah, so after 4 p.m.
Okay, I'll just send an invite. We can figure it out there.
Okay. Yep. And questions? Project 5 or 6? All right, let's take a look at Variatics first. Variatic functions are supported in C and C++. The definition of variatic function is a function that takes a variable number of parameters. And if you've used Printf a lot, then you've been using, well, if you've used Printf at all, you've been using a variatic function. So let's learn how those work. What I would like you to do is go to our apparently I have lost my browser. So, but anyway, go to a browser. There, okay. So again, go to the browser and go to the class GitHub. That would be here. And if you have not updated your clone or your copy, you should do so. There's two new directories, one called Variatics and one called bits. Let's go to Variatics first. That is the total of the README. The README says go look at the code. Okay. So I'm going to go look at the code. You could follow along, but I'm going to use the editor to do it. And all I got to do is find it. So here, and here. Where did it go on this machine? Maybe it never got onto this machine, so I guess I'll go to GitHub. I'll stay in GitHub. Okay. So let's take a look at Printf. So with Printf, you'd say Printf, and there's some char star. And then the way Printf is defined is, check this out, ... That is the signature of Printf. It actually includes ... Okay, so that is how you declare a variatic function. So what this says is,
final project for what's it called? Remaining fireworks or something?
Cephas, are you talking about something relative to class, or
Yeah.
are you having a good time?
I used this Variatics when we were making a firework project, I remember.
Ah, okay. Yeah, I heard something about fireworks. Yeah. Okay. Well, for those who didn't do that project, that was a CS2?
Yes.
Yeah. Okay. So for those of you who did not have the good fortune of having me for that version of CS2, the variatics are introduced in this way. So ... is actually an official C++ syntax. And what it says is there's some number of parameters that go there, and I don't know how many there are, and I don't know what their types are. Okay? So for instance, printf, hello, new line. Okay, so that's a proper use of hello, printf, right? The unknown number of parameters includes 0 more parameters. So this is an acceptable use of printf. You could also do this. Printf, now watch what I do here. Okay. Now, the char star encodes placeholders for the remaining parameters. In the first case, where it said hello, okay, hello, that was the start of world, I suppose. Notice there are no placeholders, therefore no parameters. The placeholders in printf are these percent signs. So not only is there a percent saying this is a placeholder, the letter that comes after it tells you the type. Okay, so for both C and C++, variatic functions you have to have some way of informing the function how many arguments it has and how many and what the type of those arguments are. And the way that you do that is up to you. Okay, now let's go to the code. You got the idea? Okay, let's go to the code.
So printf basically just like counts the percentage signs and then uses the letter after it to determine the type, correct?
Correct. That's the way printf works. But other functions that are variadic employ different techniques. It's up to the programmer.
So it's kind of like they use the get_opt function in the parameters called in order to get what they need to do.
Exactly. Well, it's like that in that the string, the option string, followed by a colon, not followed by a colon, that is a legend that is telling how many options are supported and what the options that are supported are. So it's like that, a little bit. Let's take a look at simple. So here's the definition of simple function, and it just has a count. And then ... So the way this one's written is it's just going to use the count, and all of the rest are going to be integers. Are they going to be integers or? Nope, sorry, they're going to be strings. Okay, so forget about line 29. Let me introduce some of the support functions and types. VA list is the type that you will use to get access to your arguments. And VA start and VA end, they look like functions, but they are not. These are preprocessor macros. It makes a small amount of difference. For example, you could not get a pointer to the function VA start because that function does not exist. Instead, it is a macro. Have you ever had experience with a preprocessor macro?
I know I
No.
haven't.
Don't believe so.
Okay.
I don't think we have yet.
That's why I love this course and I love teaching you this course. Okay, so the preprocessor responds to anything that starts with a pound sign, and you know it with include, right? But there's also pound define, which you have seen used to create constants. So for example, num calls, and then a tab or other white space, and 80. So that created a preprocessor constant named numcalls, and wherever the preprocessor finds num_cols uppercase, it's going to replace it with an 80. Okay, but you can go further. You can say and okay. Now this is a preprocessor macro. It is not a function. Notice there's no type information. Max looks like a function, but it has no types. That's because the types are derived from the actual parameters you supply. So if you said max of A, comma, and B, then that is going to be substituted in for the A, and that is going to be substituted in for the B. presto changeo, you're comparing char. But if you could also say, then 3.17 will be inserted here, and 5.6 will be inserted there. Now, presto changeo, you're comparing floats. Okay, so preprocessor macros are not functions. They are a way of replacing the code that you typed with other code. They are dangerous. Let me show you what you should never, ever, ever do. How about max and put in A++ and B?
Would it infinitely loop?
No, there's no loop here, but keep in mind how this is going to be replaced. So this is going to generate A++ greater than B, ternary operator, A++ and B, right? Because there's your first argument. So your first argument gets replaced here, verbatim, here, verbatim. Now you've got two increments, which is probably not what you wanted. So preprocessor macros are dangerous, especially if your arguments have side effects. Do you see this? Do you see how it's dangerous? Further, preprocessor macros do no type checking. Right? There's
So they could
not-
compare a decimal to an int, and that would cause things to go wonky.
It's possible, yeah. Yeah, so there's no type checking in the, for example, in your IDE, you won't get any red squiggles, but you could generate bad code. Like in this case, comparing types that are not compatible. Okay, so any questions about preprocessor macros?
Can the preprocessor macros work with arrays? Like, let's say I have an array of A, B, C, and D, and I want to compare that to a different array of D, C, B, and A. Would it be able to work with arrays, or does it not have the power to do so?
It does, because you could replace the definition of the macro could be more than one line of code, and it's going to get ugly, but let me show you. So let's say define foo as A and B, and you could replace that with starting out with a brace, which seems totally weird, and then for int I, well, you better put in a length, right? Otherwise, you won't know what the length is. For int I equals 0, I is less than L, et cetera, et cetera, et cetera. And then backslash ends the line, backslash ends the line, backslash ends the line until you finally get to the closing brace. A backslash with nothing after it means continue the line on the next line. Okay, so the preprocessor macro, even though you're writing it on multiple lines, it's only seeing a single line. Perhaps an example is in order. What can I use? All right. Goddamn Macintosh. That is not the editor. How do I get to my goddamn editor again, Mac? What stupid idea their UI is. Okay, let me get you to an editor. In Windows, a program has a window. You close the window, you close the program. On the Mac, you have no idea. Okay, window, no window, who cares? It's still running. Can you get back to it? No. So anyway, stupid Mac. All right, so let's create an example. Pound define, multi-line A, B, L. And it would look something like this. Either you could do it all on one line, your code. Okay, now that would be a valid macro. Or if you wanted to make it more readable, it would look something like this. And get this to line up. Nope, that goes here, and then another new line, and then that goes there. So this character says what comes on the next line should be considered part of this line. So both the before and the after creates one line of code.
Can the defined thing not recognize that it's reading multiple lines?
No, what comes after the define, the definition of the define has to be on one line. So if you want to write it on multiple lines, use the backslash character.
So what's I maybe I missed it. What's the downside of doing this often?
The downside of doing this is you will ultimately hang yourself.
Okay.
For
Why?
example, huh?
Why would that ultimately happen?
I gave you an example already. Let me give you it again. So let's say define add, and that's going to be A and B, and it resolves to A plus B. What could go wrong? So in your code, you could say int B equal int S equals add 3 and 4. Perfect, it works. That gets replaced with what really gets compiled is, right? Because it's just the macro in the preprocessor. So that's the code that actually gets compiled. But what if you did this? Okay, then what's going to get compiled is not that, but
Yeah.
okay.
Yeah, that makes sense.
So unless you meant this, it's going to end in tears.
I have a question.
Yeah,
If you were
you
to
froze.
use that same second example with the eight, okay. If you were to use that second example, can't hear me?
You were freezing.
If you put parentheses within the parentheses, A plus and the B plus work.
Right. Well, if you have to use preprocessor macros, you are definitely encouraged to not write them like this, but to write them like this. Okay, so Nate, did you see this documented somewhere? And that's what brought it to your mind? Yep. Right. So this is safer than the previous line. but you'll still get screwed sooner or later. So try to avoid preprocessor macros. On the other hand, they do have their place occasionally. But in the case of Variatics, we don't have a choice. That's the way it was designed. So let's go back to the code that I've provided. Okay, so what this function is going to do is I'm going to specify a number of parameters that follow, and all of those are going to be char stars, the way this simple is coded. So you need something like this. VA list is going to be the array of arguments. You need a VA start where this whatever your first parameter is here is part of the VA start. And then you need to end with VA end. And this also, to access, this also is a macro. Notice there's no real parameter here. It's a type. So this is assigning the type to the next argument fetched from args. Okay, so remember, I coded this as all of the extra arguments are char stars. That's why that is a char star. Now let's look at a more complicated example, which actually may be easier to understand. So here I said string format, and then the rest of the arguments. So I need my args VA list variable, VA start, and give it that template. And then watch what happens. So the way this one is defined is it's going to be given individual letters. So I, F, D, C, S. So if the letter that you're working on now is an I, then fetch an int64. If it's an F, fetch a double. If it's a D, fetch a double. Okay. I don't know why I did it that way. I don't remember, but there you go. There you have it. Okay, so here's a call to the first one. So I have to compute. Okay, there are going to be 5 arguments. Foo is a variatic function. Okay, now in less simple, instead of giving it a count, I'm giving it a format string. Okay, so you have to give a variatic function at least one parameter, and that parameter must tell you how to decode the rest of the parameters.
So VA underscore arg, will that return the next one? So like if I say, you know, find a double, will that return the next argument that is a double?
No, it interprets the next argument as a double.
Oh, okay.
Yeah, so this is going to be used in a cast. Okay. So now you know how to write a function and parse a function, understand the function that uses Variatics to provide a way of having any number of arguments. Okay, any questions?
Would you ever consider adding timestamps to the lectures on YouTube?
They actually do have timestamps. I throw that information away currently. So where I get that is when the file that I get that has the transcribed voice, has the timestamp of when that sentence began the utterance of.
I'm referring to in the YouTube video for when you say the word, for when you begin talking about a specific subject, you may have it say, this is the time where I begin talking about this topic. And when
I
you look in
understand.
the timeline, it gives a little.
Yeah, I understand. I understand. So I do have access to that information. I've been throwing it away in the past. So I will try to, I'll try to get that information included. All right, but I can't promise that because it would be a real chore.
All right. I was more just like saying, for when you say talk about, oh, I'm trying to remember when we talked about P6 or P whatever, the video, it's a lot easier to see the time step where this is where we talk about that topic.
Right. Yeah, I totally understand. I get it. It's a pain in the butt for me to implement. So I'll try. Okay. All right, so any questions on Variatics? What do you need to know? You need to know that you have to give it at least one real parameter, and that one real parameter is going to be used to decode the remaining parameters. All of the remaining parameters show up somehow in ... The VA list variable is going to be used in parsing through the remaining arguments. You have to say VA start, and then VA arg gets you, allows you to declare the type of the next argument to be fetched out of args, and then VA end. Okay. All right. Then let's start doing bits. Let's go back to the class, and I want you to write the following program. So read this and do it. Now, I'm going to ask you to write these functions using templates. Why? Because probably some of you have never seen templates before. Is that true?
I've used them.
We
I haven't
did,
used them.
we did that like daily on in data structures.
Yeah, data structure.
Yeah.
Good, good. So you have seen them. So here's
Yeah.
a little extra practice on templates. So I want you to write a function that given something and a bit number will tell you, will return true or false, is that bit a 0 or 1. Write a function that given something and a bit number will make sure that that bit becomes 0. Right? Set the bit to, and you could give it a 1 or a 0, and it will set only that bit to what you specify. Flip the bit. If the bit comes in as a 0, it will go out as a 1. If it comes in as a 1, it will go out as a 0. And see if you can figure this one out. A Boolean function that will tell you if your machine is little endian or big endian.
Professor, I have a question. What does the assert function do? I don't think we've used that until now.
Okay, I know I've mentioned it, but thank you for asking. Let's talk about assert. Okay, so in C, you would include assert.h. In C++, you could either do that or include C assert. Okay, so assert gives you, guess what? A preprocessor macro. Haha. Okay, it gives you assert. which you put in a Boolean expression. So when assert is executed, the Boolean expression will be evaluated to determine if it's true. And if it's true, nothing happens. But if it's false, the program will cause an exception at that moment, at that place. So think about what a crash is. A crash is a locomotive that's already buried itself in the ground. The bug is when the locomotive began leaving the tracks. There's a big difference between bug and crash. The crash is the end result of a bug. So what assert does for you is, so to speak, to continue my analogy, assert is like monitoring the wheels of the locomotive. And you're asserting that they're on the tracks. And if they're ever not on the tracks, you'll crash right then and there where the smoking gun is, right at the moment that the wheels left the tracks. Okay, so how do you apply that? Oh, I don't know. How about this? Void true int star a. Simple function, right? Pass the pointer. You can assert a. I can fill in some more code here, which is the same thing. A not equal to null pointer. So what's this going to do? This is just going to sit in your code. And if anybody passes you a null pointer, bam, you crash right there at that instant with a message that says on line so-and-so. You crash because A is equal to null. So this is really powerful stuff for debugging. This is powerful juju, right? You want to see an example live running?
It would probably help a little.
All right. Let's go. That's not right. Code. Okay. And I don't even know where I am. All right, I'll go in my home directory. Yeah, replace it. Okay. Okay, and in main. And here's, oh, well, oh, we could do it even right here. Well, int argc char star star argv. Assert argc equals 2. All right, that's my whole program. And let me compile it. And crash. Check that out, Thomas.
I was curious what it did because it was the first time I've ever seen the assert function.
I'm super, it is my honor and privilege to be the one to show it to you.
I could swear we did an assert demonstration last time in this class.
Yeah,
Yes,
I think it's actually last class, in all honesty.
Okay.
And you were complaining about how it didn't go away when you compiled it with optimization.
Yeah, it's supposed to go away. I mean, that's what the way I remember it. So if I turn on the optimizer, it's supposed to go away, but it doesn't. All right, well, I stand corrected.
Yeah, I just probably didn't remember then.
Okay. All right. So we got assert. Let's go back to the what I want you to write. Okay, so here's a test harness. So you can test your code. So go ahead and write this. You got to use bit manipulation. What kind of manipulation can you do with bits? This kind. All right, so start coding, start talking to each other. I'll do one with you, just one. So I'm going to take this code and I'm going to go to my editor. And I know that I'm not showing you the editor, but I'll show you in a minute. So include IO stream, include C assert, and using namespace std. And I'll go grab one of these. We'll implement it together. And then you have to do the rest. Okay, so you're seeing my code, right?
We are.
Good. And I'm going to eliminate what the hell did that do?
Oh, it's taking stuff from the GitHub and it's being wonky, I think.
have no idea what that just did.
I don't either.
And I don't know how to get rid of it.
Diff.
Okay.
Yeah.
What I thought I was doing, maybe I'll try it. Maybe I had the command sequence wrong. So Command K, Command C. Yeah, I commented all the lines out together. All right. So how do I find out if a particular bit is set?
We
You could shift it until you get there and then see if it's 0 or not.
You mean a loop?
No, I mean a bit shift.
Okay.
Shift it until how many ever, like, or you could use like C++ actually has a bit set type. You could cast it to that and ask it specifically, but that'd be the lazy way.
Yeah. How about we do it the way with bit bashing, bit twiddling, because that's the subject of today's class. So I'm going to take V and I'm going to AND it with 1 shifted by bit num times. Boom, done.
so so we're shifting 1 to the left.
Mm-hmm.
Okay. And then we're basically checking to see if at that bit number, if it's 1 and 1, we return true.
Correct.
Okay. And the second operator to the bit shift is the number of times we're shifting?
Correct. The number of bits we're shifting, the number of times we're shifting.
Okay.
Okay, so take a look at where I'm using it. I'm sending in the value of 1, and I want to know if bit 0 is on. Well, the value of 1 is the 1 is in the bit 0. So that's going to return true. Next time I try it, I want to see a false. So I'm sending in a value of 1, which is 0000001. And I want to check if the second bit is a 1, which it isn't.
Is this endianness agnostic? in general, it's not.
I would like to be able to prove this to you by testing it, but I can't because both of the machines that I have access to are little endian. Okay, by the way, I can give you now a more concise definition of what endianness is. So a little endian machine puts the more significant bytes at higher addresses. That's what little endian means. So let me go back to the iPad.
Our like intuitive interpretation is technically big endian. When I imagine one, the most significant byte, I guess, which is 1, is all the way at 0, I guess, at the lowest value. But it's internally for these architectures, it's the other way around. Am I guessing?
Well, endianness is only considered within between bytes. So within 1 byte, the bits are arranged in the order you expect them to be in. So if you had a 1 that was in a char, let's say, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so that is a 1 in a byte. The question becomes, where is that byte? If that was a short, where would that byte be? Would it be the first byte or the second byte? That's the tail of endiness. Okay.
Okay.
I'm confused what you just said about the short as being either in the first place or the second place, and that being the determinator of endiness.
Right. Okay. So what is a short? A short is 2 bytes. So in a little ND system, which I'm doing one of your assignments right now, in memory, here's 2 bytes. This is the address of the variable. It points to the first byte. That's the one that's going to have the 1 in it. And that's the one that's going to have more zeros. So this is little endian. In a big endian machine, it would be this way.
See, this would be natural. Like, this is how we represent numbers in the decimal system. So why would you use little endian instead, since it just makes it more confusing for humans?
Well, humans don't ever look at this, though, unless you're doing assembly language or for some other reason looking at the internals of memory. Because
yes, but is there an advantage that would instigate using little endian? Like some sort of architecture advantage?
I don't know if there is a particular advantage. Some machines are little endian, other machines are big endian. The R machine is both. It goes both ways, if you know what I mean. Is there an advantage to one or the other? I don't think so.
So assuming the thing is bit endian, and if you bit shift it to the right, would it become 0? Like
okay,
1.
so now I can reason through the correct answer to Cephas's original question. Once this lands in a register, it's going to be in the natural ordering. So when this is in a register, even on a little endian machine, that is bit number 0. Even though when you're looking at it in memory, that would be bit number 8, 9. in the short? So the answer, Cephas, is that the natural way of ordering the bytes is consistent with the natural ordering whenever you, as a programmer, look at it. Right, so if you're looking at it as a register, it's going to be in the right bit order. Now, where it's not correct is when you transfer over a network. So if you were to transfer this over the network, this byte will go out first, this byte will go out second. And then when you try to interpret it, if you were on a different architecture, you might be interpreting the bytes in the wrong order. Once again, sending a char, that doesn't impact because a char is sent one byte at a time and it's sent in the correct order. Ending this only comes into play when you're speaking about larger than a char. Okay, let's get back to the code you have to write. Okay, so here's mine. Now, does it make sense to put a parameter? I'm sorry, does it make sense to put an assertion in here?
No, not really.
Really? Okay, well, how about this? How about, let me set up an example for you. So here's a uint 32, and I want to find out if the 40th bit is on or not. Now, can you see a reason to have an assert?
Yeah, to see if there is a 40th bit.
Yeah.
Right,
Well, it
so,
wouldn't fail. It would just bring back wonky values.
well, all right, let's try it, see what happens.
Because it would just essentially replace all the things with zeros and you'd be shifting zeros. At least that's my recollection of what C does.
Oh, I didn't save this. Well, let's just find out. Oh, okay, I gotta comment out that. Oh, I need IO manip. Sorry. Too fancy for my own good. All right, so let's see. /a dot out. So forget about this. All right, well, it told me it was not on. But then again, that's bad programming. It's always going to return false. Wouldn't you rather know that you're being passed a bad parameter?
In general, I just said I'm pretty sure it wouldn't fail.
Oh, okay. All right, so how can we structure an assert here? This is why I thought it was going to be pretty cool to use templates.
Get size of V and compare it to the size of bit num.
Is less than what?
Size of V, although you need to divide it by, because bit num is in bytes, I mean bits, and size of is in bytes. So you need to multiply size of by like 4, I guess.
No.
Oh, wouldn't you do
8.
8?
8.
I'm an idiot. It's fine.
There you go. So now let's try it. There you go. There's a reasonable assertion that will catch the error before it causes a crash. All right, now the rest is up to you. So go ahead, write them, talk about it, talk amongst yourselves. Do clear bit, which sets a particular bit to 0. Do set bit 2, which sets it to a 0 or a 1, depending upon what you give it. Flip bit, which inverts 1 bit. Is little endian, which we kind of did. How about is a power of 2? How about is the same size? Is negative? And you've got to do it using these operators. So go ahead, start talking.
All right. So we are going to. I can tell that for set bit 2, we are going to need to do a. We can tell that for set bit 2, we're going to need to have the template for checking at the location. Then we're going to need to have that specific bit at that location become the B, which is the second input.
Mm-hmm.
So we would likely.
Will any of the functions call on other ones? Like, does the order that we do these matter?
Nope.
Not really.
Well, you could, but let's say no.
Okay.
First thing I think of when I see clear bit and set bit 2 is making a loop to go over all of the size of the thing that was
No loops allowed.
okay.
Not
No
a
need.
single loop in any of these.
There's no need.
Oh.
For clear bit, I'm just doing the similar bitwise operation with the and to check if it's already cleared. And if it's already cleared, it does nothing. If it is 1, then it will be cleared.
For set bit 2, I did an assert to check if bit num is too large, obviously.
Well, make sure you're all working on the same one at the same time. Do one at a time.
I'm just going in order.
Yeah,
So.
do clear bit. So you said when you said you're checking, so are you calling assert and then just checking to see if the V matches the bit num?
I'm doing an if V and 0 shift to bit num to see if it's 0.
Okay, no if statements.
No if statements?
No loops, no if statements.
There no need?
No need.
Okay.
You can
Could
use
we use
the operation
XOR?
not to just turn the 1 into a 0.
Okay.
That would
Could you-
turn
I'll
the
put that
0
would
into
turn
1.
the 0 into 1 actually, yeah.
Could
No,
you
I-
just
It has to be like XOR, I think. I don't
Really?
quite remember.
No, I don't think it needs to be X. Or,
Which one are we working on?
This one.
Okay.
Okay, so what does this function do?
No, I think we should just be able to AND it with the 0. If you AND whatever the bit is with 0 and you get that value, then it'll always be 0. The 0 and anything is 0.
Right, so that won't work.
It won't work? Why not?
Well, take a value, and it with 0, the whole value is 0.
Not changing anything.
That's what I.
He wants us to actually change it.
So we would set v at, or address, v at 1 shift 2 bit num is equal to 0 would probably be something similar to what we need to do.
Well, somebody tell me what to type.
V at V and symbol shift
Yeah.
7. Open parenthesis 1. I'm trying to remember what the shift right.
Well, this is shift left,
Yeah, shift.
which is what it needs to be.
Okay, then. Shift left, bit num, close parenthesis, equal to b, or equal to 0.
Good.
Like this.
Yes.
It's just always gonna,
That's not even going to compile.
you know. 'Cause that's also like saying shift and one here.
Needs to update and then return.
I think what we need to do is generate a bit field such that at the bit we want, there's
Yeah, it did compile.
1 or 0, like where it has a special value, and then we can do an operation with our main, because I think we need to duplicate v, because if you try to manipulate it directly, you'll lose bits.
You know, it's really going to hurt you when I write out the real answer.
Oh, shouldn't be
Ugh.
that convoluted.
Done.
Oh my gosh, I was right. No.
That's really it.
Can you explain why it is like that? How does that go about clearing it?
Wait. It's shifting left until it sees a 1, and then it's
Okay, well, you see how this version tests bit number bit 1, bit num.
But if you not it, then if the bit at that point is 0, it will become 1.
This is going to produce all 1s except except at bit num. That will be a 0. So if you AND all of the 1s in V with a 1, you're not changing V. Except if you AND something in a bit in V with a 0, you're going to get 0. Here, let me go to the iPad. Okay, so let's say V is 100011111. Okay, so that's V. And I want to make sure bit number 2, this one, is a 0. So 1 shifted over 2 is going to be 00000100. Now negate it. 1111011 and AND it, and with V, which is 10000111. 1, 1, 1, 1. That's a 1, that's a 1, that's a 0, that's a 1, that's a 0, that's a 0, that's a 0, that's a 1. So it's the original value of V with bit number 2 forced to 0.
I'm getting a Clang error. I don't know if I need to download a different package or something to work with unsigned long, but I'm getting a Clang error.
Here, show us your screen.
I can't.
Is it
I'm not on my computer
because
I always have issues with Zoom, but I mean, you can take a look. It's just this. It's a Clang error.
Oh, it's not. Okay, it's coming into focus. No, don't move. It's going out of focus again. Well, who told it to unsigned long?
That's just that's
My
from
code?
the call. It's from the function call itself. Yeah, with
Oh,
1 and 0.
all right. Then here, maybe you need one more include.
Okay.
Let me go back to Zoom
Mhm.
and include this. Okay, do that.
I'll let you know. C and types plus. Still getting the error.
Okay, well, I'm using Clang also.
Yeah, I just don't know. Maybe I need to update something, new package, and include, et cetera, et cetera. I just don't know.
I've got Clang 11. What have you got? G++ -- version.
Okay. Clang 12.
Ah, well, just I don't know what to tell you.
I don't know.
All right, I'm sure we could fix it with a little time together, but let's move on to the next.
Yep.
Let's move on to the next one, and that's going to be set bit 2.
Set bit 2.
I was originally thinking it would be similar to what I suggested earlier with us just doing V at moving it to the left a set number of bits and then setting it equal to B, but I doubt that's what's going to work. So,
Okay, so
wait,
here's the
Professor.
usage. So here's the usage. I got 7F, and I want to set bit number 7 to a 1. That would make it FF. Or I've got FF, and I want to set bit 7, bit number 8, to a 0. That would make it 7F. Well, that should say 7F.
Could we do a similar procedure and then OR it or something with our byte or bit, whatever?
What?
So you do a similar operation to here, and then
I get what you're saying. How would you?
I guess my confusion just is what exactly is it returning?
It's returning V.
Wouldn't we just do exclusive OR here? Wouldn't we shift over? No, that's not it.
We're still. It's trying to change the first of whatever. Yeah. It is trying to.
Well, before we have an assert, before we figure out what how we're setting the bit at all, don't we want to have an assert statement that makes sure that the bit number that we're trying to set actually exists?
Well, it would be,
Yes.
Okay,
yeah, there'd be probably two asserts there. One checking to see if the bit exists, which is that, and then another one making sure that B is either 0 or 1.
I think for B, we're going to be dealing with a lot more than just 0 or 1, though.
What?
Why
You
would you
only
do that?
accept
Oh,
zeros
wait.
or 1.
No way. Stupid. Never mind.
okay, good. Got it.
Yeah, so that's
We're going to need to. We're going to be doing something similar to clear bit, except we will want to do.
and you said no if statements, right?
Yes.
No ifs, no loops.
Why don't we just try using a similar line to the above returns for clear bit, but using exclusive B instead of not and 1. Just try it. Might as well.
You cut out. What did you say, Nate?
Try using that return line, but change your not to an exclusive OR and your 1 to B and see if that works. I don't know if it would, but it's an idea.
But you mean
No, that
this?
does make sense though. Because if it's 0, then it's not going to do anything.
Yeah, that's true.
And why are you shifting over from B?
That's
wouldn't
what
we
I'm
want-
saying. That doesn't make sense.
Come on, folks. This, by the way, is a good place to start. And then do kind of what Cephas said. Okay, in order to set a bit to a specific value, 1 or 0, you have to clear it first. Then you
So
can OR in a 0, and that doesn't change it. Or you can OR in a 1. You see?
Why do you have to clear it? Maybe I'm just not understanding that part.
Well, unless you clear it, let's say the bit starts out as a 1, and you want to set it to 0. How are you going to do that?
Oh, yeah.
So this prepares the bit for overwriting, and then this does the overwriting of just the 1 bit. All right. Let's move on to the next one. How about flip a bit?
I feel like it's going to be very similar to what we just did.
Yeah.
That being said, we'd need to take the opposite of something. It'd be the opposite of B, I guess. Well, we don't have B.
So like use the not on return B. Wouldn't it be not B or whatever the one that we're trying to?
We don't have B. We just have V.
I still think not would be crucial.
Could you repeat that, Rebecca? You got it centered a bit far away for a second.
Yeah, you're very far away.
I think not will be crucial in this part because it's the opposite, right?
Okay, everybody talk about it.
We just make it not itself, yeah. Or set it equal to not at that location.
What if you again did something like this and then ordered with the not of it? So
Okay,
you
well, tell me what to
essentially
type.
clear it, then take the not of V, and then you OR it with that.
Tell me what to write.
So I think pretty much the same thing you did up there, and then OR it with not V.
Oh, that sounds like a recipe for disaster.
Well, because Cephas, we don't have. Oh, I see. We don't have B.
No, we don't need V.
Saying V. Saying V. The,
Oh,
the
V.
not of-
Wait. No, we need to clear.
Should you turn V and not V? Would that work?
V and not V. That's guaranteed to return a constant. What constant?
0.
Yep.
Yes, we need to shift it somehow.
Yeah.
We just need to get the value and then do a not operation and then the Gucci.
I mean, I guess let's kind of work backwards. What do we have and what are we trying to get? And then we got to figure out the steps in between. We know how to set a bit. So why don't we just kind of reverse that based on bit num?
Well, do you have any operator that flips bits?
The not would no.
Not flips the bit.
Yeah, not would flip the bit.
You want to use exclusive OR?
That's it.
We're just overthinking things.
No, I just don't know what I'm doing.
Yeah. I
Yeah,
don't-
that's also true.
But I'm trying to figure it out as I go.
Well, what's exclusive OR do? Let's try, let's look at the iPad. So 0.
Only
let's do it
true
this
when the
way.
values are different.
Okay,
Yeah.
0, 1, 0, 1. So what's 0 exclusive OR with 0?
False.
Okay, so 0.
Oh, yeah.
Right. What's 0 exclusive OR with 1?
1.
All right, and 0 exclusive OR with 1, and 1 exclusive OR with 1 is 0. Okay, so that's exclusive OR. So if you're going to exclusive OR with that, so here's a bit mask, bit number 2, and you've got a 1 in there. Exclusive ORing with a 0 didn't change anything, did it? Let's see. Hello, Fredo. Go away, Fredo. All right. So let's say you got 1, 1, 1, 1, and you exclusive OR with 0, 1, 0, 0. So 1 exclusive OR with 0. What's that?
1.
1 exclusive OR with 0.
1,
All right.
0.
And 1 exclusive OR with 1.
0.
0. 1 exclusive OR with 0. Okay, that flipped a bit. Well, let's try it this way then. So what's 0 exclusive OR with 0?
0, 1.
See, look at that. Flipped a bit. Flipped a bit. Believe me? Did I get it
always
right?
believe you.
Huh?
I
Well,
always believe you.
it's your first
So do
mistake. Okay.
Now for the fun part. Indianness.
Did you go back
Yeah,
to
we
the
don't have to-
code? Yeah.
What's that?
I guess I'm still trying to, so I think I'm still a little confused on like actually, like what does the 1 shift left bit num, like what, I think I'm still confused on what exactly, what that's doing. Like I know it's
Okay.
shifting to left, but I don't get where the 1 comes into play.
Well, you need a bit. Okay, so 1 shifted left by 0 is going, let's say we're just working on a nibble, okay?
Mhm.
Is the shift amount, the bit num is the amount of shifts.
Right. So that 1 shifted left 0 is going to be 0, 0, 0, 1.
Okay, now I see.
And 1 shifted left by 1 is going to be 0, 0, 1, 0.
Huh.
And 1,
What
I'll just do
happened-
1 more. Okay,
got-
go ahead.
What happens if you do 1 shifted right by 1?
All right, it goes away. So here's 0, 0, 1 shifted right by 1. You'll get 0, 0, 0, 0.
Ooh, okay. Okay.
All right, what's 32 shifted right by 2?
Right.
Shifting right is a division by 2, folks.
Is it 8?
Yeah. So 1 shifted left by 30. That's going to be 4 billion something. Well, I can give you an exact number for this. 1 shifted left by 24 is going to be 16,777,416. Not sure. But shifting left is a multiply by 2. Shifting right is a divide by 2.
216.
216?
Yes.
All right, I almost had it right. Okay, so class is over. You have, you know what you have to do for the next class. You have to write the other functions, and feel free to work together.
Yes, sir.
You want to see
All right.
Fredo growing up? Come here, Fredo. Oh, I can't pick her up. She's too sly. Fredo's a real dog now. What a pain in the ass. What? Yeah, come on. Let's see Fredo. Bring her in. We'll immortalize her. She's a big dog now. Fredo. Here, over here. Fredo. Is she cute?
Oh,
Okay. Go away now.
He's adorable.
All right, so we'll see you on Thursday. When's your project due?
Thursday.
Also Thursday.
All right, well, I guess I'll see you at the barbecue on Thursday night, huh?
Oh, yeah. You will. Have
Yeah.
a good
Okay, bye-bye.